Yes, good afternoon, students. Today we are going to look at the ballistic pendulum. The ballistic pendulum. The ballistic pendulum considers a derivation that gives us the behavior of colliding bodies. We shall look at an expression that involves a body or a bullet that is fired at a known velocity to impinge itself in a block of a known mass and cause the block to deflect through an angle whose value we are expected to calculate. Let us consider a question that the question states that a bullet of mass 20 grams, traveling at a speed of 100 meters per second embeds itself in a block of wood of mass 1 kilogram. The block is suspended by a light vertical string of 1 meter length, and they want us to calculate the maximum inclination of the string to the vertical. Calculate the maximum inclination of the string to the vertical. In our solution, we shall begin by sketching. Assume this is our block of 1 kilogram mass, and we shall consider a bullet here of mass 20 grams. This bullet is fired with a velocity of 100 meters per second, and this mass is suspended on a string of length 1 meter. Now, when the bullet collides with this mass and embeds itself inside, it means it does not come out. The combination rises through now a known height, which we can compute. If we start from the bottom, it rises through the height h. But the string is still 1 meter. And the angle they want us to find is that theta that I'm indicating. Another candidate would take this as the height. This illustration here will still be the height through which the combination rises. Now, for us to be able to get the angle, we note that the two bodies, when the bullet embeds itself in the block, it generates a velocity that we shall call the common velocity. So we shall let V be the common velocity of the block and the bullet. And we shall use the conservation of momentum. The momentum of the bullet before collision will be equal to the mass of the bullet times the velocity of the bullet, which will give us a value of 2 kilogram meters per second. The momentum of block before collision will be the mass of the block times 0, which will give us 0. So total momentum before collision will therefore be equal to 2 kilogram meters per second, and we can label this as equation A. After collision, the block and the body are moving together with a common velocity. The total momentum will be equal to the mass of the bullet plus the mass of the block multiplied by the common velocity. And this will definitely be 1 plus 20 out of 1,000 times V, which will give us 1.02 V kilogram meters per second. This can be B. Conserving momentum means that A will be equal to B, and therefore 1.02 V would be equal to 2, implying that the common velocity V will actually be calculated to give us 100 out of 51 meters per second. 100 out of 51 meters per second. 100 out of 51 meters per second. Because we said that during collisions we have momentum conserved. And the kinetic energy may be conserved or may not, depending on the type of collision. Now we need to find the kinetic energy of the system. We will note here that the kinetic energy of the system after collision will be equivalent to the potential energy gained by the system in rising through the height h. Will be equal to the potential energy gained by rising through the height h. And therefore, using the kinetic energy as a half times mv squared will be equivalent to the potential energy, which is mgh, where m is the total mass, mt is total mass combined. Therefore, our kinetic energy of the system times the velocity that we have got, the common velocity, should be equal to the combined mass times g, we shall use that, times h. Through this calculation, of course, the mass will cancel and our h, which ideally should be equivalent to v squared out of 2g, will be obtained to be a half times this v squared times 1 out of 9.81. So the h by calculation gives us a value which is approximately that in meters. But remember that the question wants us to find the angle. And now that we have got the value of h, to find the angle, we can. To find the angle which we have called theta, we can now generate our sketch into a simple triangle, where the value of 1 meter will now decrease by the h that we have got, and then this, which is the rise, is still 1 meter. Note that we are looking at this diagram. Once again, if I may quickly make a final sketch, we are looking at this, that if this is h and the whole of this was 1 meter, now the triangle we are looking at is this, where we are taking off h. This is 1 minus h, which we are taking into our sketch that is drawn aside, and this is still 1 meter. So using the cosine of the angle we are looking for, it will be 1 minus h over the hypotenuse, which is 1 meter, implying that the value of theta, the cos of theta, will become 1 minus 0.196 over 1, because the hypotenuse is 1, implying therefore that theta will be the arc cosine of the equivalent of that difference, which definitely will give us theta now by calculation as 36.99, that we can approximate to 37 degrees rounded off. So we can conclude and say that the string is inclined at 36.99 degrees to the vertical as our conclusion. That brings us to the end of that solution, and I want to challenge the candidates and the students of A-level here that you can derive expressions for the velocity, the common velocity, if the bullet has a known mass as capital M, the mass of the block is small m, and the height through which the combination rises is h. Derive an expression for both the common velocity v and also for the angle through which the string rises from the vertical position. I thank you. God bless you.